Let's do a case study. Maybe while doing the case study, we'll get a few more questions.
Yes, sir.
Yeah. A very important concept is customer segmentation. There's a very high chance that when you join a company, when you're working on data science projects later on, there's a very high chance that you will be working on a customer segmentation project. Okay. And they look exactly similar to the one that we are doing here. Usually what we do in our course, we will take one example in the classroom that will be easy to follow, and we apply all this on a real data set. We go back to our project, then we try to apply the same concept on our project data, which is a little complex, which will take a little bit more time, a lot of other thinking, a lot of other research as well. The same template we follow here. This particular data set has been shared by one e-commerce company. This particular company, what did they do? They have taken a survey from the customers, nearly 12,000 customers. I have eliminated 200 customers. 11,805 customers are with us. Whichever data that I'm getting here, am I bringing the raw data to you? Are we applying all the techniques on the raw data?
Oh, sir. Clean
No.
data.
So basically what I'm doing is, before model building, what are the steps? You make sure that your data is explored, your data is validated, your data is cleaned. So I'm bringing the clean data, but in your real projects, you may not have the clean data. Okay. So here is the data set, which is somewhat cleaned. You have customer number, 11,805 customers. We have customer number, customer region, customer age, customer order quantity, customer type, whether overall customer is satisfied or dissatisfied. So the objective, business objective is, this particular company wants to study, is it true that customers from a particular region, particular age group, particular order quantity band, particular type of customers, prime or non-prime, are they mostly dissatisfied? If they are customers, if the customers are falling into a particular segment, most of them are dissatisfied. Is that what's happening? Do you think we have to run a marketing strategy only targeting those guys so that we can increase the satisfaction level, so that we can improve our customer experience score? What about the other way around? Is it from customers from a particular region, particular age group, a particular order quantity band, particular type of customers? Most of them are satisfied. Do we have any kind of pattern like that? If that is the case, can we target only those guys, try to do all our cross-selling, upselling? Like you observed that these type of customers are mostly satisfied. Now, those are the guys we will try to send some other products so that they can buy because they're happy with us. Is it what is happening? That's what we want to do here using the customer segmentation. Customer segmentation is mostly used in marketing. In marketing, one of the most widely used technique is customer segmentation. Do you know that? One marketing strategy is not applied on the whole data. The data is divided into various segments or the subsets. On each subset, we apply different strategies. Yes or no? We do not apply cross-selling strategies on all of the customers. We do not apply upselling strategies on all of the segments. We apply different strategies on different segments. And wherever you say marketing segmentation, sales segmentation, insurance segmentation, whenever you think of customer segmentation, the algorithm that is most widely used right now, which algorithm is that? Decision trees. Have you understood the problem statement, all of you? What are we trying to do here? Based on this data, we want to do customer segmentation and find out what kind of customers are mostly satisfied. Do we have any pattern in that? What kind of customers are mostly dissatisfied? Do we have any pattern in that? Okay. Right now, in this data set, customer type is non-numeric. It is taking like prime, non-prime. The target variable overall satisfaction is also non-numeric. It is taking like dissatisfied, satisfied. The package that we are going to use, sklearn, or in general, several other tools, the non-numeric values are not allowed. Package will throw an error that you have provided a non-numeric value. It will not run the decision tree algorithm. So we have to convert them into numerics. Simple. What do? We have the data. Whenever there is prime, we map it to 1. Whenever the value is non-prime, we map it to 0. The original variable is customer type. We try to create a new variable called customer type numeric. What are the values this customer type numeric that will take? Zeros and ones. When original variable is prime, it will be 1. And the original primary variable is non-prime, it will be 0. Okay. This is known as label encoding. There is one more way of converting text to numbers that is known as one-hot encoding. That also I'll explain at a different point later on. If you have only 2 categories like this, you can map it to 1, 0 or 0, 1. The result doesn't change. If you map it to 1, 0, prime, non-prime, in the decision tree will come like this. Left side will be prime, right side will be non-prime. What happens if you do the opposite? If you map it to 0, 1, what will happen in the decision tree? Do you think you will get the different results? what will happen? You will just get a similarity, which is a mirror image. This side will be non-prime. This side will be prime. Do you agree with that? Think about it. Do you think you will
Yes,
get an entirely different result if you do the opposite of it?
No, sir.
No.
No.
It's just a tree formatting will change, which is not a big deal. The same thing, overall satisfaction, dissatisfied is mapped to 0, satisfied is mapped to 1. Because non-numeric values are not allowed. Text data, these sklearn package or in general, most of the packages, they do not work with the text data. If you're working with the text data, there is a different algorithm or different packages need to be used. That text data also we'll discuss later on. Okay. Now with this, a little bit of pre-processing, we are ready. These are all our features. The features are region, age, order quantity, customer type, numeric. So if you look at the overall X data, the features data that you have to supply, I'll go to e-commerce data. I'll take all the final features that are required that I'm going to send it to the model. So that means in this data set, there are 11,805 rows. If I'm taking only features, how many columns will be there?
4.
4 columns will be there. Why data? Go to e-commerce data, take only overall satisfaction column, which means in this data set, there will be 11,805 rows. How many columns?
1.
1. Your X data, Y data is ready. We are ready to do the model building. Most often, model building is simply 2 lines of code. Have you observed it? Data cleaning and all that is a lot, lots and lots of lines of code. Maybe when you are building logistic regression, you may have observed model building is just 1 or 2 lines of code. But that indeed will call a lot of lines of code behind the scenes in the form of that function. So these are the 2 lines of code. First, configure the model. My model is equal to tree.decision tree classifier. Okay, that's the first line. I want to build a decision tree. If you remember earlier, we used to say my model equal to logistic regression, my model equal to linear regression. And then we give one more parameter, max depth. This is very important parameter. We are going to discuss this in depth a little later on. Just to make a note of this, make a side note here. We're going to discuss very much in depth right now in this session after a little while. But as of now, you take this as syntax. Before that, I have to explain one more concept, then I'll come to this. As of now, you simply take, this is how you configure the model. Then you say model.fit, supply values of X, supply values of Y. What will happen when you say model.fit, supply values of X, supply values of Y? The whole decision tree algorithm will take place. Start with a root node. Use a variable that has the highest information gain. Split it. Go to this node, split it. Using the variable that has highest information gain. Split it. Using the variable that has the highest information gain. When do you stop it? When purity is achieved, then stop it. When purity is achieved, then stop it. No more further purity can be achieved, then also stop it. No more further purity can be achieved, then also stop it. That whole decision tree algorithm will take place with this one line of code. Yeah. Is D tree a variable or a function? Tell me what is the specification of a function? Think of it. What is a function? A function will have input parameters, isn't it? So in this, tell me a function, give me a function. A function, there is a shortcut to look at the function. A function will have these kind of things. So here, what is a function in this one? Decision tree classifier is a function. What about this one here? What is a function?
Fit.
Fit is a function.
Fit.
So find a function here. In this one,
Dot map.
map is a function. Okay. But here, decision tree is a kind of like, strictly speaking, you can call it as a variable. It is called an object. Okay. Like this is a, I mean, deep if you go into that, it is called an object which has different properties and all that. Okay. But what I would say is you can call that as a variable. Okay, but it is definitely not a function. A function means something that you can use. Okay. Is that clear? Yes. All right. Now, once you say model.fit, this whole algorithm will run in the background. This decision tree will be created. Everything will be stored in this decision tree object. This is that model object. Have you seen these type of model objects earlier? Have you seen them? These type of model objects? Where have you seen them? Have you created any other models earlier? Think of it. Have you seen a logistic regression model object earlier? A linear regression model object? Similar to them. This is a model object which has all the information in it. What we can do is like this model object has the information, how many records are here, how many of them are 0, how many of them are 1, which variable was used here, how many records are here, how many records are here, how many of them are 0, how many of them are, all that information is stored in this model object. Then what do? We can use this model object. We can use plot underscore tree option. What we will do? We will supply that model object to this plot underscore tree function. What is the plot underscore tree function doing here? It will simply take this decision tree, understand all the model variables from there, and try to give you the decision tree diagram finally. The remaining are optional parameters. If you want to fill it with colors or whether you want to have a round shape and all that, this doesn't matter. But what you need to do is you have to use this plot underscore tree function to draw this decision tree. So what we are going to do right now is we're going to import this data set, step 1. Do this little bit of pre-processing, step 2. Look at all these features, make sure that you're preparing X and Y data. Build the model, draw the model finally. If everything works fine, then you will have this decision tree diagram printed in front of you. Then what we will do, we will try to analyze this decision tree, interpret this decision tree, process this decision tree, finally get to the results. Make sense? Yes. Let's get to the code file now. Import the data set, go through step by step, one by one. Once you have this decision tree, send me a confirmation. Okay. Once you have this decision tree, we will then discuss the output, how to interpret this decision tree. If everything works fine, you must be having this decision tree printed in front of you. What we will do is we will take a quick break, then regroup in 10 minutes. Then I'll explain you what exactly these numbers are and how do we interpret them. Is that fine?
Yes, sir.
While you are building this decision tree, if you're not getting this, quickly let me know. If everyone gets this decision tree, then we will go for a break.
I got so.
Yeah, I think it works without any glitches. This code, if you are not getting right now, anyway, you're going to apply the same code on your project at that time. You can look deep into it. You will get definitely some errors and all that, but try your best to resolve them. Okay. Once you search here and there, you will get the results. Okay. At the end, I will anyway share one solution for every project that you have picked. Okay. But before that, let's try to give it a shot. Let's take a quick break. 15 minutes break. Would that do? Let's meet at 9:40 a.m. And then I'll explain you how to interpret the decision tree. And there are some other subtopics within the decision tree that we will get into. Okay.
Yes.
All right. Yeah. I'll see you right after the break. Welcome back, everyone. Once you're back at your desk, send me a confirmation. Once you're back at your desk, send me a confirmation message. Looks like nobody is there. Let's give a minute for others to join in. All right. All right. Earlier, we got the output for the decision tree. Let us discuss the output. How do we interpret that? Okay. We first start with the root node. In the root node, you'll first get how many records are there in the root node. The number of records are given with the name samples. How many records are there? How many samples or how many records are there? So look at the dish.
11,800.
Is that correct? Can you verify that in the data? Is there a place where we can verify that in the data? Those many records, overall number of records. At the root node, you have full set, isn't it? So this is correct. Then you will have the next value, which is the target variable value, y value. Always zeros are shown first. Then the count of ones are shown next. Number of zeros, number of ones. If your target variable is taking 0 and 1, always zeros are shown first by default, ones are shown next frequency. If your target variable is non-numeric, in our case, it is taking satisfied, dissatisfied. Then alphabetically, whichever is first, alphabetically dissatisfied is first. So always dissatisfied is shown first, satisfied count is shown next. So out of 11,805 customers, how many customers are dissatisfied, which are shown in the initial number? How many customers are dissatisfied?
6,408.
6408. How many are satisfied?
5397.
5397.
If your y variable is 0 or 1, then it will be count of zeros, count of ones. If your y variable is non-numeric, then whatever is alphabetically first, that will be shown here. Then what decision tree will do? It will try to divide the data exactly into two subsets. Okay. The variables that we have used here, what are the variables that we have used? We have used age of the customer. We have used order quantity of the customer. We have used which region the customer belongs to. We also have used customer type. So what do decision tree do? It will calculate the information gain of age, order quantity, region, customer type. Use that variable which has the maximum information gain. So it will go to the root node, calculate the information gain of all the 4 variables, use that variable which has the maximum information gain on the root node. So decision tree will do all of that, and it will display the variable that has the highest information gain within the root node itself. So instead of showing it here, it will show it within the root node itself. So within the root node, which variable has the highest information gain?
Age.
Look at the root node. Don't look at anything else. The variable that has the highest information gain on the root node is shown within the root node itself. Which variable has the highest information gain once again?
Order quantity.
Order quantity. Instead of showing it here, where is it shown? Is it shown here in the diagram? No. Where is it shown? It
On
is
the
shown
top
here.
of it.
Order quantity. So that we don't confuse that any other variable. Order quantity is the variable that was used. Was it picked randomly? Do you think order quantity was picked because it's the second variable or randomly one out of those 4? What was the criteria once again? On which criteria order quantity was picked?
The higher information gain.
We have calculated the information gain of all the 4 variables. Order quantity has the highest information gain. Now, order quantity is a tricky variable. Can you split order quantity at 20 and say this is order quantity less than or equal to 20? This is order quantity more than 20. Yes, we can do that. Can you split order quantity at 30? Is there a possibility? Can you split order quantity at 40? Is there a possibility? 35, 45, 55. You can split order quantity at any splitting point, what decision tree will do is it will try all these splitting points and choose that particular splitting point. Choose that particular splitting point where it observes. Since order quantity can be split at multiple splitting points, decision tree will use all these splitting points and it will finally choose that splitting point in order quantity where it observes. Tell me what really matters to us finally.
Highest information gain.
So where it observes highest or the maximum information gain. Apparently, at what point, if you split order quantity, you will have the maximum information gain. That calculation also decision tree has done internally. That is also given to us. Tell me the point where you will get the maximum information gain. Exactly at what point we have to split order quantity?
40.5.
If you split
Less than
exactly at
equals to
40.5, this side will be always less than or equal to 40.5. This side will be more than 40.5. So that is what is mentioned here. Order quantity 40.5, less than or equal to 40.5 is this side, more than 40.5 is this side. Now tell me, out of 11,805 customers, how many customers have order quantity less than or equal to 40.5? How many customers are there?
7,397.
That is given in samples here, 7397. How many customers have order quantity more than 40.5? More than 40.5?
4408.
4408. Out of these guys, how many are dissatisfied? Number of dissatisfied.
6374.
6374. Always D is first. Satisfied are
1023.
how many are dissatisfied here?
34.
34. 4374. Okay. Now, is it a purest subset? Is decision tree going to stop here? What is the
No.
next step decision tree will do? It will try to find any other variable that can make it further pure. Now, apparently, on this subset, which variable has the maximum information gain? Which variable? Age has the maximum information gain. Can you split age at multiple points just like this?
Yes, sir.
So all those multiple splitting points will be tried. Exactly which splitting point, where exactly I have to cut? How is that decided? The point where we achieve.
Maximum information gain.
So apparently when you split age, exactly at what point you will achieve maximum information gain?
29.5.
29.5. This side is always less than or equal to 29.5. This side is more than 29.5. Out of 7397, how many customers have age less than or equal to 29.5? How many?
379.
Out of them, how many are dissatisfied?
4.
How many are satisfied?
375.
So how about this one? What is the name of this segment? Tell me. These are all the customers whose
Age is greater than 29.5.
specifically, if you have to tell absolutely correctly what we have to say, these are all the customers whose order quantity is less than or equal to 40.5 and age is greater than 29.5. Do you agree with that?
Yes, sir.
Simply, if I say age greater than 29.5, I may have a lot of customers, isn't it? Out of these are the customers on two conditions. How many customers are there? 7018.
7018.
Out of them, how many are dissatisfied? 63, 70, 648 are satisfied. Okay. Now come here. 379 customers are there. Out of them, 4 are dissatisfied, 1% dissatisfied, 99% satisfied. Do you think we have achieved almost pure subset, or do you think we should split it further to get absolutely 100 and 0 kind of scenario?
No.
Do you think we
Almost
can
clear.
stop it here? This one,
Yes,
this
sir.
node? Yeah. So decision tree has stopped this, and this is also almost like 91%, 9%. Maybe is it possible to get even a better variable that can make it better than this? Decision tree will try it. If it finds no other variable that can make it better than this, then it will stop it here. How about this one? Which variable was used for further splitting? Which variable was used?
Age.
Age. Is there a guarantee that in every problem statement you should get the same variable here and here? Is there a chance that there can be some other variable here in some other scenarios?
Sir, there can be some other variable.
There can be some other. Is there a rule that this one should have the same variable? There is no rule. In some other scenarios, you can have some other variable. Is there a rule that exactly if age is used, it has to be split at exactly 29.5 to get the maximum information gain, or it can be some other splitting point? Everything is depending on this subset, isn't it? So what is the splitting point here?
20.5.
20.5. Always this side, left hand side is less than or equal to
Less than.
20.5. This side is greater than 20.5. Earlier it used to be given like this, but now they are not giving. They want us to understand. Okay. How many records are here? 475, 6 comma 469. Is it almost pure? Almost
sir.
pure, isn't it? 3933. Again 28 comma 3905. Is it almost pure?
Yes,
Is
sir.
it fair to say we have taken the whole data, which is somewhat impure, 50-50 chance, we have made it into best pure subsets? Is it fair to say we have achieved fairly pure subsets, isn't it?
Yes, sir.
Yes,
That
sir.
is what decision tree is doing. What does decision tree do? It takes the whole data as input. It tries to divide the data into purest possible subsets. Is it true that every time you have to get pure subsets, or does it depend on the data and the variables that are used?
It depends
Sir,
on
data and the
It depends on the
Depends
data,
on the data we use.
isn't it? It definitely depends on the data. All right. This is the decision tree output. Now, when you think of it, this output of the decision tree is coming like a diagram format. Like, is this the model? Like, what do you mean by model? Like, in general, what is the final output? Let's say when you're working on machine learning projects, what is the final output of the model that a client is expecting from us? For example, a client has given us the data and we are done with model building. Everything is done. We are ready to use that model. Maybe you have built a credit risk model. I have to use that model to predict whether a customer will be risky or non-risky. I have to do it. Then what is that I will be taking from you? What is the deliverable from your side? Are you going to send me the Python code file? Your data cleaning, like you have the Python notebook file. Are you going to send me that as the final deliverable? Do you think I'm going to use that as a client?
no, sir.
Do you think your Python code, does it matter to me? What code you have followed and all that? In fact, whether you have used Python or R or SAS, does it matter? It doesn't matter. Your final model deliverable is not the code file. Nobody cares about your code. What code you have written, how efficient are your code? No, nobody cares about that. Is it some kind of data set that you will be delivering as a final model? No. Is it some kind of predicted values file you're delivering as a model? No. Your final model deliverable is simply one equation. That's it. If you're building a regression line, this is your final model deliverable. Yes or no? If you give me this equation, what I need to do? I need to supply the values of X. I will get the predicted value of Y. If this value is correct, that's what I don't ask any questions. Yes or no? Imagine a scenario, somebody wrote a proper super duper Python efficient code, but the predictions are wrong. But somebody wrote a very clumsy Python code, it was not efficient, but the predictions are right. So in a data science project scenario, which project is given importance? Let's say this is project 1 with very good code, bad predictions. Project 2 with very clumsy code, but good predictions. Which one will get
Actually,
higher
two.
priority?
Project
Two.
2.
Project 2, isn't it? As a data scientist, always your focus should be on results, isn't it? Making sure that you are giving the right predicted values. This is the final output deliverable in regression. Maybe 2-3 months of your effort will finally come to this one equation only. Yes or no? Do I really care what kind of imputation that you have done while doing the data cleaning, etc.? Does it really matter in the final model prediction time? If you're building a logistic regression model, y equal to e power beta naught plus beta 1 x1 and so on plus beta k xk divided by 1 plus e power beta naught plus beta 1 x1 and so on plus beta k xk. This is the logistic regression line equation. That is our model. Similarly, what's the model in decision tree? If you think like that, because decision tree is not like this, where we can write an equation. It's a kind of diagram. So in the decision tree, the model is nothing but set of rules. You give set of rules as your model. These rules come from the leaf nodes. Where do these rules come from? Leaf nodes. So you have this, right? How many leaf nodes are here in your decision tree? How many leaf nodes are there?
4.
4.
Leaf node 1, leaf node 2, leaf node 3, leaf node 4, leaf node 5, leaf node 6. L5, L6, are they qualified as leaf nodes?
No.
Are they? Why are they not qualified as leaf nodes? Why can't we call them as leaf nodes? What's the property of a leaf node?
They should be pure.
A leaf node is the terminal node, isn't it? Below that, there's no other node. Then it is called as leaf node. Okay. This is not a leaf node. Why? Why it is not a leaf node? Because below it, there are 2 child nodes. A leaf node doesn't have any child node. Okay. So you have 4 leaf nodes. You'll be writing 4 rules. Okay. Rule 2, rule 3. These 4 rules put together will be your decision tree model. These are like if then else rules. If order quantity is less than or equal to 40.5 and age is less than or equal to 29.5, then the predicted value, if a customer has order quantity less than 40.5, age is less than 29.5, what's the predicted value? Satisfied or dissatisfied?
Satisfied.
Because this is D, this is S, most of them will be satisfied. In a similar manner, can you tell me rule number 2 associated with leaf node 2?
If order quantity less than equal to 40.5
If order quantity less than or equal to 40.5
and age
and
greater than equals to 29.5.
greater than 29.5 equal to is covered there, then predicted value is
Dissatisfied.
dissatisfied. Most of them are dissatisfied. D. Tell me rule number 3. If
Order quantity greater than 40.5.
Order quantity is greater than 40.5 and
Age is
Age
less
is
than
less
equal to
than
20.5.
20.5.
20.5. Then the predicted value is
Satisfied.
because this is D, this is S. The last rule, if
Order quantity is greater than 40.
order quantity is greater than 40.5 and
Age is
age
greater
is
than 20.5.
greater than 20.5, then the predicted value is
Dissatisfied.
Satisfied.
satisfied.
Sorry,
This
sorry.
is D, this is yes. In fact, can we combine these two rules and say that if order quantity is more than 40.5, no matter what is age, can we say they will be satisfied?
Yes,
That
sir.
Yes,
either
sir.
you can combine them or you can leave it as it is also. The result will not be different. These are the rules that will give you the predict. This is the model. What is a model? A model takes input. And if you run that input to the model, then it will give you the output, predicted value as the output. That means if you have a list of new customers, these are the new customers, customer 1, customer 2, customer 3, customer 4. Can you tell me the predicted values? For customer 1, what's the predicted value? Is he going to be satisfied or dissatisfied? Customer 1.
So dissatisfied.
Satisfied.
Customer 1 has order quantity of 20, age of
70.
70. So
Dissatisfied.
he will be falling in this segment, mostly dominated by dissatisfied customers. Do you agree with this, all of you? Confirm that to me.
Yes, sir.
Yes, sir.
Are you on the same page? Yeah. Tell me about customer 2 then. If you have understood that, run that through the model and tell me what will be the predicted value for that guy.
Very much satisfied.
Order quantity is 15. Age is again 15. There's a high chance that that customer would be satisfied because he falls here. Most of the customers who are previously, yes, very much satisfied guys, he will also be seen the same way. How about customer 3?
Satisfied, sir.
Customer 3 has an age of 60. Not age, first we have to see order quantity. Order quantity of 75. Age of 60, he will be falling here. So that customer will be satisfied because most of the customers there were satisfied previously. How about the last customer, customer 4?
Satisfied.
Satisfied.
100% pakka.
Cost,
What is the order quantity? 35.
35.
What is the age?
55.
He will be
Greater
falling
than
here.
dissatisfied.
Yes or no? Is it satisfied or dissatisfied? Customer 4 is dissatisfied. Do you agree with that? All of us
Yes,
are
sir.
on the same page, right?
Yes, yes, sir.
Yeah. We need to be careful with this. But are we going to do these predictions manually like this?
No, sir.
What we will
No,
do,
sir.
we will use model dot predict function. Yes or no? Supply this as a data set X. Then automatically you will get the predicted values. Has anyone used model dot predict function already earlier in a different scenario with a different model?
Logistic regression.
Logistic regression, linear regression, at those places we can use model dot predict. The same thing we will use. So that is the model that will give you the predicted values. But we are manually doing it just to get a feel of how these rules work. These decision tree output is nothing but a set of rules. Decision trees are very much used in the places where you want a quick result because there is hardly any math. If you want to deploy a decision tree model on SQL, isn't that easy? Compared to logistic regression, is logistic regression easy to deploy on SQL? Can you put logistic regression equation on SQL where it will take the data and give you the result? That will be a little difficult, isn't it? But can you put a decision tree model on SQL server? Is it possible? Decision tree model deployment is simply applying some rules, isn't it? Filter conditions, yes?
Yes,
Where
sir.
you want a quick result. There also you can apply this decision tree model because it is just set of rules that will run that will give you the predicted value. But what do good data scientists do? Are they in a hurry to get to the predicted values as soon as they build the model? Is that what good data scientists do?
No.
Tell
No,
me,
sir.
all of us are good data scientists. Model building, we are not in a hurry to go for predicted values after model building. What do we do? Model building, right after model building, we are in a hurry to do the
Model validation.
model validation. Very good.
Validation.
Model validation is the important piece. Have you understood why I'm emphasizing so much on model validation? Because anybody can build the model. Any data can be used for building the model. Any model will give you predictions. But do you think those predicted values are always, can we trust them from any model? Model building must be followed by model validation.